Bismillahirrahmanirrahim. Assalamu alaikum everyone. We are going to conduct another video tutorial on signal and system course. In last video tutorial, we started a new section of even and odd signals, and we discussed about even signals in detail. We covered mathematical point of view and graphical point of view and how one can actually identify even signal and odd signal uh, in graph and mathematical equation. So I suggest if you have skipped that tutorial, I will suggest it that please go and watch that tutorial because it will make the foundation of this tutorial as well. And we are going to take our knowledge on the next level, and we are going to add the odd signal into the same discussion. Okay, let's discuss about odd signal. So what is an odd signal? So just for the sake of a definition, uh, it is a signal which must satisfy the following mathematical relation. And what is that relation? The relation is this one. And relation says x of minus t should be equal to at minus times of x of t. So that means we will check signal's value at some negative index, and then we will check the signal's value at the positive index, right? Let's say I check the value of the signal at minus 4. So I choose x value at minus 4. Let's say it was equals to 6. I'm just taking random values, and then I will check the value of the signal at plus 4 because it says x of minus t, and the next thing says x of t. So let's say the value of the signal is at 4. It should be equals to 6 because 6 is going to be placed in this equation, and then we can actually change, or we can actually put these relations. 6 will come from here, right? And minus sign from the mathematical relation, and 6 will come from here. So do you think that relation holds in this specific case? No. Keeping these values in mind, we can easily suggest that this equation doesn't verify this relationship, right? So that relationship must be hold for an odd signal. So what should be the value, or what should be the difference? So you can say that if I'm going to amend these values, so if signal value at minus 4 was equals to 6, so it should be what equals to minus 6. Then and only then it will come back to here, and there will be minus from its original value and minus from the relation, and then both of them will become equals to 6, or one can actually say that the relation will be satisfied. Okay, let's take one more random value just to illustrate one important fact which one must understand before we go for examples and identifying signals as an odd signals in mathematical and graphical domain. So what is that fact that I want to explain here? Let's say I take one more example, x of t, or let's say I'm going to take some dummy value. Let's say x of minus 5 is basically equals to minus 6, right? And let's say x of plus 5 equals to plus 6. So I'm just taking again a random value as I told you. So this is minus 6 and this is plus 6. And if you are going to put these values in this relation, so this relation will hold. But what is to be understand here? You see what is actually one can actually infer from this information. This is minus 6 and this is what plus 6. That means and you are checking a signals at some arbitrary negative index, and you are taking the same time in the positive index as well, which is 5, right? So basically minus 5 and 5. So in other words, one can also define this fact that they are basically at arbitrary. If you take any arbitrary time index value, you check it at in negative domain, you check it at positive domain. So both of these values should be additive inverse of each other, right? In case of even signal, remember we used to say that the negative time index value and the positive time index value. So let me write it for you to understand it much better. So in case of even signals, we actually defined it that negative time index should be equal to positive time index. But what is something different in odd signals? For odd signals, negative time index must be additive inverse positive time index. That is something very much important. And I hope you know that what is additive inverse. Additive inverse means if you add them up, result should be what? 0. Because if you add -6 and +6, result would become 0. So this thing is something general fact for odd signals. Now let's explore these uh, definitions in mathematical examples and graphical examples. So I'm taking a example of the signal. Let's say x of t is equals to simple t. So it is a simply defined signal, or in other word, it is defined for the time interval from -infinity to +infinity. So uh, how we gonna check this signal? We will have to test this relationship, and that relationship involves x of minus t. So let's say I'm gonna test this signal, let's say at 5. So x of 5, what will be the value of x of 5? So if I'm going to put the value of the 5 in this relationship, so it will become simply x of 5. So equals to 5. So x of 5 is equals to 5. Similarly, if I'm going to test x of minus 5, so it will be what? It will be simply -5, right? But now we need to verify the signals relationship with this relationship. So let's say x of minus t. X of minus t means x of minus 5, which is equals to -5. And the relationship is minus, and x of 5. X of 5 is 5. So you see, this equation is basically holding. This equation is actually correct. So that means this is a correct example of odd signal, right? You can see that this is uh, this is a correct example. That means you are verifying this relationship. You can also verify it for some other value. For example, let's say I'm going to verify it for x of 6. So if I'm going to test this equation, x of 6 will be equals to x of -6 will be equals to -6 and minus x of 6. Let's say I'm going to test this value. So it will be equal to minus times, and x of 6 is simply 6. So both of them are basically equal. So we again verify this signal as a odd signal. So this signal is generally holding this relationship, or generally verifying this mathematical relation. That means this is a correct example of odd signal. I'm going to show you the graphical relationship of this signal as well. So I'm going to plot this signal. So what if I'm going to plot the signal, how it will look like? So this is the graph of the signal, uh, x of t equals to t, and one can easily notice that this signal is positively increasing if we go to positive time domain, and if we go to negative time domain, it is negatively increasing. If you remember, by inspection, the graph of the signal, we can easily tell that the signal is even or not. And for even case, what we have to do, we have to actually fold this complete portion over the negative time domain. That means we have to actually fold the positive time domain values over the negative time domain values. And if they overlap completely, then we will term that signal as an even signal. From the mathematical inspection, we have already verified that this signal is not an even signal, rather it is a odd signal. So let's say if I'm going to apply that even trick on this graph, so what is going to happen? So that is the negative x-axis, and we know that negative x-axis area will remain same. So graph of negative will be same as it is. And what we are going to do, we are going to fold this positive axis area over the negative axis area. So this is going to be folded like this. This complete portion of the positive x-axis has been folded over the negative domain. So do you think is this signal is being overlapped with the negative values? No, of course not, because this is the area of the positive folded values and this is the area of original negative values, and they are not being overlapped. So from the graph, one can easily tell that this is not an even signal. And of course, we already knew that thing because we have already verified that signal in mathematical analysis that this is a odd signal. So what we have to do in odd signal, one more extra step, and that extra step would be the original signal, the negative time index value, we will keep it as it is. Actually, what we have done so far, we have folded this area over this area, right? So that means we have folded positive x-axis over the negative x-axis, right? Or positive time domain over the negative time domain. But we will also fold the positive y-axis. So that is the positive y-axis area, and we will fold it over the negative y-axis. So if we are going to make it, then this portion, right? This portion will eventually, this line will eventually go down here. How? Let me show you. So if I will plot it, it will look like this. So you see now the negative values and the positive values, complete signal is being overlapped, and you can see that this area indicates now complete overlap. So that is the trick of odd signals that one should verify from the graph. If you fold signals positive x-axis value over the negative x-axis value and then fold the positive y over the negative y, then signal will completely overlap. And if that completely overlap happens, then you will call that signal odd signal in graph. Okay, this is another example of odd signal, and we will verify from the graph whether the signal is odd or not. So what we have to do, okay, this blue color portion indicates this is the positive index values, and this negative x-axis values, or this brown color indicates the negative x-axis values, right? So I'm just showing the two different colors so that one can easily understand. So if I'm going to overlap this positive indexes values over negative indexes value, or fold the x-axis over the negative x-axis, so what is going to happen? This thing I will indicate here. So negative portion is as it is as it is. But if I'm going to draw the folded version of the positive x-axis value, it will look like this, right? And if I'm going to now you can easily say that they are not being overlapped, so this is not an odd even signal. And for odd step, you have to go one step forward. And again, let me draw the first the even values. And now we will fold the positive y-axis over the negative y-axis. So remember, uh, this is the positive y-axis area, or this is the negative axis y area. Or you can also say that the first this quadrant and this quadrant, I will overlap or fold it over the last two quadrants. So that means it will eventually look like this. So it will be folded over it. And now for the sake of your visualization, I'm just taking different sizes of a square, otherwise they will completely overlap since it is a odd signal. So after that complete overlap visualization, after two different folding procedures, in first fold we actually folded the negative x-axis over the positive x-axis, and in the next fold we actually fold the positive y-axis over the negative y-axis. So that thing indicates that signals are completely overlapped now, and the overlap area, if I'm going to show you, this is the overlap area. Yes, this is the overlap area. And you say that they are completely overlapped, there is nothing mismatch in overlap, so that thing indicates that this is a odd signal. So this is how one can actually verify that this is an odd signal from the graph. Okay, so we discussed all the concept of odd signals for the continuous time signal, and we will also extend the same knowledge for the discrete time signals. As in last video tutorial I did, I actually explained complete stuff concept for continuous time signals only, but this is also valid for discrete time signals as well. So if I'm going to show you the same mathematical relation that we are observing here in case of continuous time, so discrete time signals, this relationship will look like this, that uh, x of minus n should be equals to the negative of x of n. Or if I just highlight these equation in discrete time, that means x of n is equals to minus of x of n. So this equation you can also test in discrete time signals. All the concepts remain same and there will be no change in it. So I hope you understand the odd signals. Uh, that's it from this video tutorial. If you have any question regarding the concepts of odd signal or even signal, you can post your queries in comment section. Thank you so much for listening.